Hey guys, this problem is called as point grid and it was fairly an easy problem. So in this problem we are asked to do an operation here given by the code. I ask you to read this what the operation actually means, and then we are given an array of size n. We are given an array. So what does this mean? So I have taken an array of 5425 as example. So from this array means that we are about to construct 2D matrix like this, and the first element means that the first row has 5 ones and then rest of it is filled with zeros. I mean 0 till infinity, but we don't have to write that 0 till infinity and all. And then we are given 4 means 4 consecutive ones and then rest filled with zeros up to infinity. And then next one is 2, that means 2 consecutive ones and then rest filled with zeros up to infinity. So that process continues, and here it has 5 ones. So what we are supposed to do is that we are asked to find a special, and we are asked to mark all these ones here. We have to mark all these ones. So for marking all these ones we have a special operation. It is called as, this operation is given here in this code. So what does this operation do actually is that, suppose we are going to select one unmarked location, and unmarked location has to be 1. So unmarked location means all these locations are unmarked, all these cells are unmarked from the initially. So what we are doing is that we are going to select one of the locations, one of the cell, which is 1, and then we are going to apply that operation. In each operation we can mark all the cells to the diagonal of it till we encounter a 0. So here we can see that we can mark 1 here. So here we can mark 1 and this one here, because we can mark all the cells to the diagonal till we encounter a 0. So if we do that operation, we can mark all these ones by starting from here, but here we can only mark this because we can't mark this because we encountered a 0, so we can't mark this. So again we can't move past this 0. So if we repeat this operation, we will start here and mark all this, we will start here and mark all this, we will start here and mark all this, and then we will repeat that operation. So what we are about to find is that what is the minimum number of operations that we have to do so that all the ones in this 2D matrix are marked. So as you can see, the number of operations I took here is 1 2 3 4 5 6 7 8 9 10. So this is the minimum number of operations. Why? Because I have utilized the utilized the diagonals very effectively, because I have utilized the diagonals to the maximum extent actually. So it is fairly inefficient to actually construct this 2D matrix and then proceed with the implementation. It is really inefficient because our time limit is 1 second. So what we have to do is that we have to come up with another way to actually solve this problem. So one thing you can understand is that we have to mark all the elements of the all the ones in the bottommost row. Why is that? Because there is no other diagonal which can fill this, because the only diagonal that can fill it should be starting from itself, because there are no elements to below this level. It is the bottommost level. So as you can see, the bottommost level has 5. So what we can say is that we can say that our cost, that is a minimum cost, will be 5, or we can initialize a variable called cost to the value 5, because that's the minimum value. And then proceeding each level, you can see that, suppose I am marking all these elements of 5 and doing operations on all these elements in the bottommost level, all these 5 ones. So what you can see is that if I do all these, suppose let us assume that this level, that's the level above 5, all has 1. Let us not consider 0. It has all everything is 1. So you can see that these 5, marking these 5 elements of the last row can actually mark first 4 elements of the next higher level, and can actually mark first 3 levels of the next higher level, and actually can mark first 2 levels of the higher level. So if you didn't understand what I meant, I'll show you like this. Suppose that you can see that this 2 can be marked from these rows, these diagonals, what do you mean? So let us assume that these are all 1 actually. So by marking 1, by doing operation on all these ones in the lowermost level, we can actually do n minus, that is the lower side. Let's assume that this is n. We can do actually n minus 1 operations on the next higher level automatically, because it's actually diagonal. So we can actually do n minus 2 operations on the next higher level. So here for 5 we can already 4 places are already occupied. I am assuming that everything is filled with 1, and then here 3 places are occupied like this, and here 2 places are occupied like this. So what we mean is that by moving each level up, we are actually decreasing the amount of ones which we can take from the previous level. Did you get it what I mean? If you didn't understand that, I will explain it using another way. So let us see this example. So here, as you can see, I have assigned the cost to 5. So this is our minimum cost, and I am actually taking a value called as minimum value. So what does this minimum value is? Minimum value means that minimum value is actually 5 here. So what this minimum value means is that this is the minimum value, and in each iteration which I am going from the bottom to up, I am going through each row from the bottom to the top. While going from each row to the next row, I will decrease my minimum by 1, which means the minimum is the number which number of rows, number of ones which I can fill in the next level due to the previous level. So here, once I reach 2, I can find that the minimum value in the 2 value, I can find that the minimum is actually 4, because I decreased 2, I decreased 1. So as you can see that there are no 4 ones here. If there were 4 ones, actually these 4 ones will be already marked because of the ones present in the lower level, that is the 5th level with 5 ones, I mean. So but there are only 2, which means that all the rays which are going from the lower level to the next level will be stopped here because of these zeros. So this rays can't go past this 0. So actually we have to update our minimum value to 2, because only these two rays will get passed through. Only these 2 rays will be passed through, and all these rays will be blocked. Which means that actually what we have to do is that if the size number of ones in the next higher level, that is next higher level is having value 2, if it is less than the minimum value, then what you have to do is that we have to update our minimum value to be 2. So if it is less than that, we will update our minimum value to be 2. So as you can see that the minimum value is 2. So if we will move on to the next iteration. Here, as you can see, is that the value is actually 4, and we have decremented our minimum in each iteration. Now our minimum value is actually 1. So what does this 1 mean is that the first element of the 4 is actually covered by this 2. That is what is meant. Covered by this 2, covered by this 5, I mean, because the rays can pass through from this one to this one to this one. The rays can pass through, and actually this is already covered and is mean already marked, so we don't need to mark. So as you can see that the 4 is actually greater than minimum. So this is another case. 4 is actually greater than minimum. Here 2 is actually less than minimum, so we updated the minimum value and then decremented the minimum. If the value here is greater than the minimum value, that means that we have to mark some extra elements. Here we didn't need to mark any extra elements because all these elements were marked by the previous levels. So here we have to mark some extra elements. Here we have to mark 3 more elements. So what we are going to do is that we are going to update our cost to be 4 minus minimum. our update our cost to be 4 minus minimum. So here 4 minus minimum means 4 minus 1, which is actually 3. So our cost, we are going to increment our cost, I mean we are going to increment our cost to 4 with by 4 minus minimum. So our cost will be 5 plus 3, actually 8. So I'm going to, we have incremented our cost by 3. That is actually cost plus c equal to the value, which is the, suppose w of I is the array, w of I minus the minimum value. So this happens if this condition happens if w of I is actually greater than the minimum value. This means that the minimum value can't actually account for all the ones in that level. So suppose we are going back to this, and then we are moving to the next level. So before moving to the next level, as you can see that the number of minimum value, that is the minimum value, that is the number of diagonals have changed. So what you can say is that we are reassigning that number minimum value to be w of I, that is actually 4. So why are we doing this is that actually we have colored this, we have actually marked these elements also. So we got 4 rays going from this one to the top. So since we have got 4 rays, and then we again minimum is set to 4, which means minimum is set to w of I. In each step we are setting minimum to w of I, and then we are actually decrementing the minimum in each step. So when we decrement the minimum in each step, like we are decrementing it by -1, we can see that when we move on to the topmost level, we can see that it is minimum value is actually 3. What does this 3 mean is that these first three of these ones are already marked. So that is meant by this. So what does the mean by 3 is that now our minimum value is 3. So when we reach the topmost level, w of I is actually 5, and then our minimum value is 3. So here you can say is that w of I is actually greater than the minimum value, which means 5 is greater than 3. So actually the almost all the ones are not already colored by the previous levels. Here you can say sees that first 3 of them are colored, first 3 of them are marked, I mean, but the rest 2 of them are not marked, it's actually unmarked. So we have to mark them specifically. So by doing that, we do this operation, cost is equal to, we have to update our cost, that is we have to mark those 2 as well, so it requires additional cost. So we will do the same operation, w of I minus min, which is actually cost plus equal to 2, 5 minus 3, which is 2. So as you can see that we have updated our cost, added our cost to 2. So our total cost will be 10. So as you can see that this we have updated our cost in each step. Like this step we have updated or initialize our cost to 5. In this step we don't need to add any cost because it's already covered, it's already marked by that. So how do we know that? We know that the minimum value is actually, that is the w of I is actually less than the minimum value, so it's already covered. So if I move on to the next step, we can see that w of I is not greater than, it's actually greater than the minimum value. So we have to mark some extra ones here, and then we mark those extra ones and we add 3 to the value, that is 5 plus 3, 8, and then we update our w of I as well, minimum as well. And then we move on to the next step and find that first 3 of them already marked, because but the w of I is actually greater than minimum value. So there are two of them has to be marked again, which is given by the cost, which can be found from this formula, that is cost plus equal w of I minus minimum, and we have to add 2. So 8 plus 2, 10. So this is exactly as we did here. As you can see that we have these 3 are marked. We first marked all the levels, these 2 are already marked, this is already marked, then we mark these first 3 elements of this level, and then this marking these 3 elements will already mark the first 3 elements of the first level, and then we have to mark these 2 additional levels. So the total cost of this operation will actually be 10. So this is the implementation. The implementation is really straightforward. So I will show you the implementation. So here is the we are reading the input n, and we are actually reading an array w and reading the array. So we are initializing the count to w of n minus 1, and we are initializing the minimum value to w of n minus 1. What this means is that the count is actually initialized to n minus 1, and it is a minimum count. That is, there is no count less than this. So we are going from the bottom level, that is the bottom row, to the top row. And if the w of I is greater than the minimum value, it's that if w of I is greater than minimum value, we update the count, that is we add w of I minus minimum value. That is these many ones have to be colored, that is these ones are not colored by the previous levels, so these ones have to be colored extra, so that will account to the cost. So we are, in both the cases, we are updating our minimum value to the w of I. Why we are updating w of I value to w of I? Because if it has greater than, if it is less than the, if the next level, if this next level has, this next level has 2, this level has 2, this level has 2, which means that the rays cannot pass through these zeros actually. So only rays after 2 can pass through, so the minimum value has to be updated to 2. So in this case actually you can see that the rays are actually, you can only can pass through this, but there are few additional ones here, and we are also marking those ones too. So our minimum value will be updated to 4, and those rays will pass through here. So this concept is actually a little interesting one, because you have to visualize this ray concept and blocking of ray by these zeros. Just the most convenient way to visualize this. And then we decrement the minimum value while we move up to the each level or up to the each row, as I said earlier. So and then we print the count. So this was this question. So you just have to run it and see. This was the question, and this was a straightforward implementation to this question. Hope you all understood the question and enjoyed this question as well. I really enjoyed doing this question. And yeah, see you guys. Bye.